Okay, so we have an exponent problem here that also involves a little bit of substitution. So we're given a value of our variable, in this case a is equal to -2, and we're given an equation. We're going to plug this variable into the equation and then evaluate it. What does this equation say? Well, we have 3, right, to the -a plus 2. Well, if a is -2, think about the fact that you're plugging a into this variable here, which is reading -a. So -a plus 2. What does that mean? When you see -a, you can think of this as whatever a value you have multiplied by -1, or essentially reversed, right? So whatever a value you have, if I plugged in a 2, it would become -2. But what if I plug in a -2? What's going to happen? Well, we already have a -a, so plugging in a that equals -2, we get -2, right? Think that I just kind of substituted -2 for this a value. But remember, there's already a negative sign here, so there's two negative signs now. So you have -2 plus 2. What are we going to get there? Well, the opposite, or negative of a -2 is what? Well, it's 2, right? Plus 2 is 4, so this is 3 to the 4th. And what's that equal to? Well, 3 to the 3rd is equal to 27. So 3 to the 4th is just 27 times another 3. And you can break this up, of course. 20 times 3 is 60. 7 times 3 is 21. That's equal to 81. So this term is equal to 81. And we can keep going now. And we're subtracting 2a squared to the a power. So what's going to happen here? Well, we have 2 times -2, right, squared. And that's being raised to the -2 power. Okay, well, let's break this down in pieces. First of all, let's square -2. -2 squared is equal to -2 times -2, which is a positive 4. So we have 2 times 4, and that is being raised to the -2nd power. What's 2 times 4? Well, that's equal to what? That's equal to 8, right? And 8 to the -2nd power is equal to 1 over 8 squared. Definition of a negative exponent. And that equals 1 over 64. So what do we have here, right? We have these two pieces. We have 81 minus what? Well, minus 1/64. Now before you go and try to convert and get different denominators, I just think to myself, well, I have 81 and I'm taking away a 64th. So logically, how many 64ths are in a whole, right? Well, if you break something into 64 pieces, it takes 64 of them to make a whole. It takes 64 64ths to make a whole number. What I'm saying is that if you take 1/64th away from 81, you still have 80 and 63 64ths. Imagine if you added back this 1/64th, you would get right back to 81. So this is our answer in this problem. You can leave it as a mixed number. All right, thanks a lot.